Have you ever just stopped and thought about the sheer complexity of nature, that incredible entangled bank Darwin talked about? You know, teeming with life, all connected, all shaped by evolution.
It's an amazing image, isn't it?
Totally. But then look around you at our world. The device you're listening on right now, buildings, roads, all these networks.
Right, the human-made stuff.
Exactly. And it makes you wonder, can evolutionary biology really explain, I don't know, a church choir? Or gravity as a concept, or a space station? Can it explain those things as well as it explains, say, a finch's beak?
That is the really deep question we're getting into today. This deep dive is all about trying to unravel maybe the trickiest part of a human story.
How we got here.
Yeah, how evolutionary processes could possibly lead to a species like us.
Wow. So different from everything else.
Yeah.
I mean, if humans evolved intelligence, language, this ability to build these huge societies and artifacts, why didn't other species, especially the great apes, our closest cousins, why didn't they get these things too?
It does seem like a puzzle. It's definitely not as simple as it might look at first glance, is it?
Okay, so let's unpack this. We've got some really fascinating sources lined up, taking us through this journey, looking at our unique abilities versus the rest of the animal kingdom, right down to our genes. So our mission here is to pull out the key insights, right? Figure out the origins of this. You called it the entangled bank of human culture and how that connects back to the animal roots of the human mind. You know, it's funny, Darwin himself, he did amazing work on the natural world, obviously, but he admitted he really struggled with where our intellectual faculties came from. He basically said he didn't have the ability or knowledge to figure it out fully.
That's right. He acknowledged the challenge.
And this is where it gets really interesting.
It really does. Because, on the surface, you might think, okay, humans are just really smart primates. Intelligence, language, culture that let us change the planet. Simple.
Seems logical enough.
Okay. But when you dig a bit deeper, that explanation starts to fall apart pretty quickly. It raises all these difficult questions. Like, okay, why don't chimps build rockets or space stations? They're smart, right?
Right. No chimp astronauts that I know of.
Exactly. And you see animal cultures like, food preferences passed down or bird songs, but they don't have laws or morals or institutions or symbols in the way human culture does. There's a fundamental difference there.
What about tools? Lots of animals use tools.
They do, but the key thing is animal tool traditions don't seem to ratchet up. They don't get progressively more complex over generations like human technology does. A chimp termite fishing stick today looks pretty much like one from decades ago.
That really highlights the gap, doesn't it?
Yeah.
So when people hear about this, what's the big misunderstanding you often see?
Often it's this idea that it's just a matter of degree, like we're just a slightly more advanced version. But think about it. The difference between, say, a chaffinch singing its song and Puccini's operas, or a chimp using a stick to get ants versus, Michelin star hot cuisine.
Ah, yeah, quite a jump.
Or an animal maybe counting to 3 versus Newton figuring out calculus. The scale of the difference is just immense. It seems like this unbridgeable gap sometimes.
And that presents a real challenge to simple evolutionary explanations.
Absolutely. Because Rachmaninoff concertos and space stations, they didn't exactly pop out of famine and death and natural selection in the same direct way that, say, camouflage does.
Right. Designing an iPhone doesn't automatically mean you have more kids.
Precisely. So the puzzle becomes, what are the laws or processes that account for this relentless technological progress? Or even just the changing fashions in art and music. It's not classic natural selection driving it in the same way.
Okay, so if it's not just standard natural selection driving these specific things, what does that tell us about how we build our world? Like, let's look at some specific human behaviors, how we cooperate, maybe?
Yeah, cooperation is a huge one. Think about building something simple, like a school.
Okay, a school building. Seems straightforward.
Well, to an evolutionary biologist, it's kind of mind-boggling. The scale of cooperation is just astounding. You've got all these workers coordinating foundations, windows, wiring, everything.
Right, lots of people working together.
And think bigger. The companies making deals, buying materials, shipping things, subcontractors, financing.
Global supply chains.
Exactly. Tools, nuts, bolts, paint, all coming from different places, made by different companies. And most of these interactions are between people who aren't related at all. They're based on promises of getting paid later.
That kind of vast, anonymous, long-term cooperation. You just don't see that elsewhere.
Nowhere. No bird builds anything more complex than a nest. No termite colony deviates from building its mound. Nothing remotely like a human construction project exists in any other species on Earth. It's hard to even wrap your head around it sometimes. Like your morning coffee.
Yeah.
The beans from one place roasted somewhere else, shipped by another company. That involves a level of cooperation that, would make an ant colony look simple.
And it's not just the building itself, right?
Yeah.
What about what goes on inside the school, like teaching?
Precisely. Active teaching, where someone deliberately sets out to educate someone else, that's incredibly rare in nature.
Really? You don't see animals teaching their young much.
They might help their offspring or close relatives, sure, because they share genes. But human teachers, they spend huge amounts of time and energy teaching kids they're not related to at all.
And that doesn't directly boost the teacher's own evolutionary fitness in the classic sense.
Not directly, no. And even the payment system, money, coins, bank accounts, that's all part of this giant, complex web of human cooperation and institutions that's unique to us. Why do kids sit and learn about ancient history or, abstract geometry?
Things that aren't immediately useful for survival, maybe.
Right. Other animals learn what's practical, what's useful now. You don't see monkeys teaching their kids about, famous nutcrackers from centuries ago.
Yeah, good point.
And think about things like uniforms, fashions, school uniforms, doctor scrubs. Why do we do that? Other animals don't have fashion trends. These are all uniquely human things.
Okay, this brings up something people often mention, that stat about humans and chimps being, 98.5% genetically similar?
Ah, yes, the famous percentage.
It makes it sound like we're practically identical, which makes this huge cognitive gap seem even weirder, doesn't it?
It really does. But that statistic is, let's say it's widely misunderstood. And frankly, some of our sources call it wildly inaccurate if you think it means chimps are 98.5% human, or that their genes work just like ours do.
Okay, so what's wrong with that interpretation?
Well, first off, that 1.5% difference, that's still about 35 million different DNA letters across the genome. That's a lot of changes.
35 million. Yeah, okay, that sounds like more than almost identical.
Exactly. But even more important than the number of different letters is how the genes are used. Think of it like having the same building blocks, but a completely different instruction manual.
How they're assembled, when they're turned on or off.
Precisely. Tiny changes in the regulatory parts of the genome, the bits that switch genes on or off at different times or in different places, can have massive effects.
Like dimmer switches.
Kind of like dimmer switches, yeah. Or maybe complex timing circuits. For instance, the sources point out that about 6.4% of human genes don't even have the same number of copies in chimps. That's a significant difference in the parts list.
And does this affect the brain particularly?
Hugely. A disproportionate number of the genes that differ between humans and chimps, or are regulated differently, are active in the brain and nervous system, and mostly they're more active in humans.
Reading too.
Leading to our brains being over 3 times larger than a chimp's, and also structurally reorganized in really important ways.
Okay, so the building blocks might be similar, but the final structure, especially the brain, is radically different because the instructions changed.
That's a good way to put it. So the bottom line is humans and chimps aren't so biologically similar that we should expect them to be behaviorally or cognitively alike. The gap is real.
But it's not necessarily a problem for evolution.
Not at all, because that gap wasn't instantaneous. It was bridged by all those extinct hominin species, Homo habilis, Homo erectus, Neanderthals, the Australopithecines, our ancient relatives. They represent the steps along that unique evolutionary path.
Right, connecting the dots.
Exactly. It just reinforces that our evolutionary journey took a really unique turn.
Okay, that leads us nicely into the actual experiments, the studies that have tried to pin down these unique aspects of human thinking. Compared to our relatives, what really jumps out from that research?
Well, quite a lot, actually. Let's start with cooperation again. There's a classic experiment called the ultimatum game.
Okay, how does that work?
Simple setup. One player gets some money, say $10, and proposes how to split it with the second player. Player 2 can either accept the offer, and they both get the money, or reject it.
And if they reject?
Neither player gets anything.
Okay. So, rationally, player 2 should accept any offer, even a tiny one, right? Because something is better than nothing. And player 1 should offer the minimum possible.
That's the purely selfish, rational prediction. But that's not what humans do.
What we do?
We tend to make pretty generous offers, often a 50-50 split. And crucially, player 2 often rejects offers they see as unfair, usually anything below about 20%, even though it costs them money.
So we punish unfairness, even at a cost to ourselves, driven by social norms.
Seems like it.
Yeah.
Fairness, social norms, reputation.
Mm.
These things matter to us. Now, when you run a simplified version of this with chimpanzees,
What do they do?
they consistently act like that rational, selfish player. They maximize their own returns and show very little concern for fairness to the other chimp.
So their behavior is actually closer to the purely economic model.
It is, yeah, which strongly suggests that along the human line, we were selected for traits like fairness, sensitivity to social rules, maybe even a willingness to punish unfairness.
Fascinating. What else? Theory of mind.
Right, theory of mind. That's our ability to understand that other people have their own beliefs, intentions, desires, goals, that their mind is separate from ours.
Understanding what someone else is thinking.
Basically, yes. Now, chimps show some basic precursors. They can figure out what a human experimenter wants, maybe, or understand simple goals or perception to some extent.
All right.
But, and this is critical, there's really no solid evidence that chimps understand false beliefs.
False beliefs, like understanding that someone can believe something that isn't actually true.
Exactly. That's considered the gold standard test for a robust theory of mind. Human kids usually get this around age 4. And adult humans, we can juggle multiple layers of understanding, thinking about what she thinks he believes about her intentions. You know?
Like navigating social situations.
Precisely. Other apes seem to struggle even with understanding simple first-order intentions consistently.
Okay, so cooperation theory of mind.
Yeah.
What about language? That seems like a big one.
Huge. Animal communication systems. They're typically quite limited. Specific signals, usually tied to immediate situations, think vervet monkey alarm calls for different predators.
Danger signals, mating calls.
Right. Usually single signals, rarely combined in complex ways. The honeybee waggle dance is a famous exception, conveying abstract information about location, but it's still quite rigid.
And human language.
It's just entirely different. It's open-ended. We can create basically an infinite number of new sentences. We master symbols, grammar, syntax.
What about those experiments trying to teach apes language? Washoe, Kanzi.
Yeah, the talking ape studies, they were impressive in some ways. The apes learned many signs or symbols, hundreds even. But
no real grammar.
Exactly. There was no hint, as one source puts it, of having mastered grammatical structure or syntax. They could string signs together, maybe, but not in the complex, rule-governed way humans do. They learned words, perhaps, but not language in the human sense.
So still a massive difference.
A world of difference, yeah, between a chimp asking for a banana and, well, a Shakespearean comedy.
Okay. One more area, morality. Do animals have a sense of right and wrong?
Morality. There are lots of romantic notions out there, and many anecdotes of animals seeming to show sympathy or fairness, like making up after a fight.
Reconciliation behavior.
Yes, but the scientific take is more cautious. Animals definitely have rich emotional lives, but that's not the same thing as having a moral system.
So those anecdotes, they could be interpreted differently.
Often, yes. Reconciling might just be about repairing a valuable alliance or reducing stress or achieving some short-term goal. It doesn't necessarily imply a concept of forgiveness or justice. I mean, some fish show similar reconciliation behaviors after fights.
Do we think fish have a sense of forgiveness?
Probably not, right? It raises that question of how we interpret behavior. And for every story of apparent moral behavior in an animal, you can find many, many more instances from the same species showing purely selfish, even exploitative behavior.
So expressions of what look like moral tendencies are pretty rare.
At best, they seem to be rare events in other species, not the basis of their social systems like morality is for humans.
Okay, so we've got these profound differences: cooperation, theory of mind, language, morality. And the genetic similarity isn't as straightforward as it seems, and traditional selection doesn't fully explain things like iPhones. So what is the big explanation? What's the core argument for how we got so, well, exceptional?
The core argument really boils down to this idea of cumulative culture.
Cumulative culture. Okay, what does that mean exactly?
It means the extensive accumulation of shared, learned knowledge and iterative improvements in technology over time. Basically, knowledge and skills building up generation after generation.
Like standing on the shoulders of giants.
In a way, yes, but it's even more than that. Think about something really simple, like a paperclip.
Okay, a paperclip. Seems basic.
I think someone just invented it, right? But the sources show its history involved centuries of tinkering. from straight pins to bulkier clips to different wire shapes, slowly refining it over time before we got the standard gem design we use today.
So even a paperclip wasn't invented by one person in one go.
Nope. It illustrates how technology changes and gets more complex through lots of small improvements and modifications by many people. And the crucial point is no single person could invent a space station, obviously, but probably not even a modern paperclip from scratch. It's a collective building process.
Right. It relies on previous knowledge and innovations.
Exactly. My own research actually started by looking at why animals copy each other, which they do, because it's a shortcut to finding good solutions that others have already figured out.
Learning from others makes sense.
Right. And how they copy, they're often strategic about it, like copy what most others are doing or only copy if learning yourself is difficult or dangerous.
Okay.
Now, the key insight is this. In our ancestors, natural selection favored individuals who were better and better at copying accurately and efficiently. This led to a really heavy reliance on learning from others.
We became super learners.
Kind of. We started building up these huge data banks of valuable knowledge within the group, passed down through social learning. And this started to change the game. It fundamentally transformed the pressures acting on the primate brain itself.
How so?
It became kind of runaway process. Better social learning allowed for more complex tools and behaviors, which then created selection pressure for even better learning, maybe bigger brains, more innovation.
A feedback loop.
Exactly. Accelerating cycles of evolutionary feedback. Culture started driving cognitive evolution. Brains got bigger, intelligence increased, partly because there was this growing body of cultural knowledge to acquire and use.
And this runaway process favored teaching. You mentioned teaching was rare.
Yes, because once culture becomes really important, it pays off to invest in making sure others, especially your offspring, learn it effectively. So costly behaviors like active teaching emerged, helping to transmit complex knowledge more faithfully.
Which allowed culture to become even more complex and diverse.
Precisely. And then you add sophisticated language into that mix alongside teaching, and suddenly you have the ingredients for the kind of large-scale, complex cooperation we see in humans.
And genetics confirms this interaction.
Yeah, the genetic data points to this unprecedented interaction between cultural and genetic processes. Culture wasn't just something humans did. It started actively shaping our genes, particularly those related to brain function. It fueled this acceleration in our brain's computational power.
And this process is still ongoing.
Absolutely. It continues today, driving technological change, artistic diversification, scientific discovery, and even our massive population growth. It's an autocatalytic process culture feeding back on itself and on our biology.
So the way you put it before, we're more than just souped-up apes.
Exactly. Our evolutionary story involved a different kind of evolutionary dynamic. All species are unique, of course, but humans are, you might say, uniquely unique because culture became such a powerful driving force in our evolution.
So human minds aren't just built for culture.
They are, in a very real sense, built by culture.
Wow. That really is a fundamental shift in perspective, isn't it? Moving away from just seeing us on a continuum to recognizing this unique feedback loop with culture as the key driver.
Yeah.
So what are the biggest takeaways then? What does this neatly unique view mean for how we understand ourselves?
Well, it means that figuring out human uniqueness was, and still is, a huge scientific challenge. But we're starting to get some really compelling answers, backed up by evidence from genetics, archaeology, cognitive science, anthropology.
Across different fields.
Yes, and it suggests that our intelligence, our language, our cooperation, our technology, they aren't just things that evolved solely because of external pressures like climate or predators. To a large extent, they are creatures of our own making, products of this unique gene-culture co-evolutionary process.
We shaped ourselves in a way.
To a significant degree, yes. Which leads to a final thought, perhaps a bit provocative. Consider this. Our amazing capacity for complex culture gave us symphonies and science and space travel. But that very same capacity also enables things like incredibly organized warfare, complex financial crime, and, planet-wide environmental damage on an unprecedented scale.
A double-edged sword of cultural capacity.
Exactly. So if our minds are truly built by culture, as the evidence suggests, it raises a really important question, doesn't it? What responsibilities do we have then to consciously and intentionally shape the cultures that, in turn,